So let's look at our second hypothesis test. It is desired to show the mean weight of a metal component is greater than 4.5 ounces. We want to use all of this information and conduct a hypothesis test. All right, so let's start with stating our null hypothesis and our alternate hypothesis. The alternate hypothesis is written right in that first sentence. We want to show that the mean weight of a metal component is greater than 4.5 ounces. All right, so notice the mean again, so we know it's the mean. So our mean is greater than 4.5 is our alternate. Mean is greater than 4.5. All right, now from that, the null is easy to get. Remember, the null is going to be the same thing except an equal sign here, mean equal to 4.5. So that's our first step. We've got our alternate, we've got our null hypothesis. Second step, let's do our test statistic. Here's the test statistic up here. Let's go ahead and fill in, and I'll use my draw feature there for that. So X bar is 4.59. Our mean is 4.5. Our standard deviation is 0.504. And our sample size is 10. And it didn't tell us it's normal, but we're going to assume that this was a normal distribution. All right, so this gives us 0.09 on top. And let's go ahead and put the bottom in our calculator. That gives us 0.15. 9378 794. And I'm not going to round off until after I do this next division. Let me get ready to look it up. All right, so I'll put that in. And I'm going to round to 1 decimal place since that's what we have on our chart. And this gives us 0.6. All right, now, remember before when we were doing things when we were finding probabilities on our standard normal chart, if we had a greater than, we had to subtract from 1. And the same thing is true here. So we're going to look up 0.6, and whatever we get, we're going to subtract it from 1. And that will be our p-value. So let's look up 0.6 on our chart. 0.6, and that gives us 0.7258. And I'll go ahead and do this subtraction. And I get 0.2742. So this is our p-value, 0.2742, if I could write. Now remember, if the p-value is smaller than alpha, we reject the null hypothesis, but 0.2742 is not smaller than 0.05. So in the case where the p-value is larger than alpha, we do not reject the null hypothesis, but what we say is we fail to reject the null hypothesis. We don't say keep the null hypothesis. What we always say is fail to reject the null hypothesis. And one of the reasons for this is researchers have essentially not shown it with this particular study, whatever it is, but that does not mean that the null hypothesis is necessarily correct. So they say fail to reject. In other words, we haven't come up with enough evidence to prove what we wanted to prove, but we'll just do another study and see if we've made mistakes in this first study. Now, generally, of course, if we fail to reject over and over again, that tells us that this probably was the correct hypothesis. All right, now, We failed to reject the null hypothesis. That means for us, our statement is going to be, there is not enough evidence to reject the null hypothesis. And I've turned it into typing mode so I don't have to struggle through the writing that. There is not enough evidence to reject the null hypothesis. The mean weight of the metal component appears to be 4.5 ounces.